Hello everyone. Hope you all are in good health. Myself, Mrunal kshirsagar, and my team members are Prerna Mashar and Ranveer Patil, guided by Professor Dr. S.M.M. Naidu sir. Our project is Underwater Image Enhancement using RCNN. RCNN is Recurrent Convolution Neural Networks. It is family of machine learning models for computer vision and for specifically detecting objects. It is an algorithm for detecting multiple objects in an image. This is outline of our project. Introduction. When we capture images underwater, it gets distorted due to various scattering effects. These effects absorb the light and make image blur and masking details of the image, and it may lead to producing noise. And this noise will make our image more distorted. The light waves absorbed depends on various factors such as suspended particles in water and salinity of water. The dispersion of light and color effects are major sources of distortion in underwater image. The visibility and contrast of the captured image lowers the quality of image due to scattering of light. The change in color leads to varying degrees of attenuation with particles present in water such as sand, minerals, and so on. These particles in water, along with absorption of natural light and scattering effect, is an image taken underwater. The image matting application to underwater depth map derived by the general direct channel method is a novel approach method. In this method, novel RCNN method is used to generate the feature map. We have used this method for high accuracy of image. Need, which is significance, various weather conditions like rain, fog, haze will cause versatile visual effects of temporal domain in images or videos will be lower the quality of underwater vision system. Haze image is an opaque medium like water droplets which will degrade the outdoor vision of image because of atmospheric absorption and scattering. Its removal is an extreme task as distortions depend on the unidentified scene depth data. The function of the distance between object and camera is known as underwater image. To remove the distortion in an underwater image, we need to improve image processing and computer vision algorithm with less execution time. So, the objectives of our project are to study and review the existing system with methodology advantages and its disadvantages of the system, to develop the underwater image enhancement using RCNN, to implement the system in Raspberry Pi system with the camera module, to evaluate the performance of the system using evaluation matrices like peak signal to noise ratio, mean square error, and structural similarity index matrix are the evaluation matrices we used. Literature survey. We have worked on the papers on enhancing the lower quality images using unsupervised color correction, in which for that we have proposed an unsupervised color correction method for underwater water images quality enhancement. UCM is based on color matching contrast improvement of the RGB color model and the contrast improvement of HSI color model. Firstly, the color cast is concentrated by equalizing the color values. Secondly, an improvement to the contrast alteration method is useful to increase the red color by stretching the red color histogram towards the outmost. The blue color is concentrated by stretching the blue histogram to the minimum. Second proposed method is a detection method based on sonar image for underwater pipeline tracker. Proposed an unsupervised color correction method UCM for underwater image quality enhancement. It is difficult for operator to identify the pipeline from the images. Furthermore, the observation of underwater pipelines is deadly and time unbearable, and it is easy to create mistakes due to the exhaustion and interruption of the operator. Then the study focuses on rising images producing algorithms to distinguish the pipeline repeatedly. Using the proposed image processing technique, firstly, the images are improved using the Gabor filter, and then these images are used for edge detector. The third one is low complexity under the image enhancement based on dark channel prior. Blurred underwater image is always an irritating problem in deep sea engineering. They proposed a component and complexity underwater image enhancement technique based on dark channels before. Our technique employs the median filter in this plane of the soft matting method to estimate the depth of map of the image. Furthermore, a color improvement method is adopted to improve the color contrast for the underwater image. The tentative results show that the proposed approach can well improve the underwater image and decrease the implementation time. Also, this technique requires fewer computing reserves and is well appropriate for implementing supervisions and underwater navigations in real time. Fourth one is underwater image enhancement by wavelength compensation and dehazing. In the system, the deepness map, that is distances between the object and camera, is expected. The foreground and background within a view are segmented. By managing the effect of the artificial light, the haze occurrence and inconsistency of the wavelength attenuation along the underwater broadcast path to the camera are corrected. The water deepness in the image seen is predictable according to the remaining energy ratios of diverse color channels obtainable in the background light. Fifth one proposed system is significance level of image enhancement technique for underwater images. In this, underwater imaging is fairly demanding in area of photography, especially for low resolution and normal digital cameras. Some problem arises in underwater images such as partial range, visibility, low contrast, and non-identical lightning blurring, intense artifacts, and color diminishing and noise. This research concentrated on color diminished. The major application of typical computer vision techniques to marine images is mandatory in dealing with thought problem. Both automatic and manual level methods are used to record the mean values of the stretched histogram. The sixth one proposed contrast limited adaptive histogram equalization for underwater image enhancement. By improving the quality of the underwater image has received sustained attenuation due to the run-down visibility of an image which is caused by physical properties of the water. Hence, they are presented a new technique called hybrid contrast limited adaptive histogram equalization CLAHE color spaces that specifically developed for underwater image improvement. This technique operator on RGB and HSV color spaces and both results are joined together using the Elkidin rule method. This tentative results show that the future approach considerably improves the visual quality of underwater images by enhancing contrast as well as dropping noise artifacts. So, gap identification in our literature survey, the presented methods have neglected the techniques to reduce the noise issue which is presented in the output image of existing the fog removal algorithms. Not much effort has focused on integrated approach of adaptive histogram equalization and dark channel prior. The problem of uneven illumination is also neglected by most of the researchers. Now, I will request Prerna to explain the further slides.
Hello everyone, my name is Prerna Masha and now I am going to explain the project implementation of our project. So this is the hardware module for our proposal system. Here we use the Raspberry Pi 3 module B, that is the third generation module. So for a Raspberry Pi we gave a two input. First one is the power supply, that is battery, and the second one is the camera. Here we use USB camera, which is 24-bit RGB camera, and the output of the Raspberry Pi module is gives to the monitor. First, The hardware image is taken as an input. Input image contains different types of noises. A mask of 3 by 3 is applied over the image, and the middle pixel of the mask is exchanged by the median value of the neighboring pixels. In most of the non-sky patches, there exists at least one color channel that has some pixels whose concentration is very low, and that is nearly equal to 0. Homogeneously, the smallest amount of concentration in a such patch is close to 0. That channel is referred as dark channel J. So, basically in our project, here we first take one underwater image using camera and change it into the grayscale. The grayscale contains the number of suspended particles in a water, turbidity and a salinity of water, or etc. This cause effects such as the blurring, masking details of the image and may lead to producing a noise. So we remove color blurriness. By managing the effect of artificial light, we optimizes some particular parameter like haze occurrence and the inconsistency in a wavelength attenuation. Along the underwater broadcast path to the camera, after that we apply a convolution method. If its optimizes apply variance method of no gain remove the color blurriness present in the captured image. And now we will see a network architecture of our proposed system. So here is the network architecture of our proposed system. And now we will see our software model for a proposed system. So a relationship between haze-free image J and the haze image I. So basically here the haze means the fine dust, smoke or a light vapor causing lack of transparency of air. Haze image means a reduction in visible contrast of a scene due to the scattering of light by particles suspended in air. The I of x divided by t of x is equal to j of x plus a of 1 minus t of x divided by t of x. The ratio of I of x equal to t of x can be considered as a whole h of x is equal to j of x plus b of x. So, the transmission map estimation. CNN algorithm CNN algorithm is used to obtain the map the relationship between haze image and transmission. CNN means a convolution neural network. Basically, a CNN algorithm is a deep learning algorithm which can take in an input image, assign importance to various aspects, objects in the image, and be able to differentiate one from to the another. The characteristics of a convolution output can be obtained from the equation convolution equal to f of x w plus b, where x represents the image matrix, w represents the convolution kernel, and x represents the convolution operation, and the b represents the offset value, and the f represents the RULU function. Here, the RULU function means the rectified linear activation function or RELU. For a short is a piecewise linear function that will output the input directly if it is positive, otherwise it will output 0. The second layer is a slice layer. Its role is to slice the input in a terms of dimensions. That is a 16 by 14 by 14 feature map obtained by the previous layer is subjected to the slice operation to convert the size to 4 by 4 by 14 by 14, which facilitates the processing of the next layer. The third layer is the LY layers. Uh, So the third layer is the altwise layer. There are three operations for altwise layers. This is product, sum, and max. In a product layer, we do a dot multiple, and in a sum layer we add minus, and in a max layer we take a large value. We divide the four feature maps into the one group and maximize them. The feature map with the dimensions of a 4 by 4 by 14 by 14 is mapped to a 4 by 14 by 14. After that, the fourth layer is uh, in a fourth layer we use a multi-scale mapping method to increase the accuracy of a feature extraction. The multi-scale hierarchical feature is a scene level feature that has an invariance and a consistency in the scale space, allowing a larger image environment to be applied to local recognition decisions, including approximately centered and scaled targets and hierarchical natural attributes. This provides a good basis for predicting a potential target categories. And the fifth layer uses a 7 by 7 convolution kernel to perform a pixel level. So the pixel level neighbor maximum extraction on the input image, which can better preserve the feature on the texture, overcome the local sensitivity of the feature map, and it reduces the of the solution of the propagation map. After that, the last layer is a convolution layer to convert the input data into the feature map with the dimensions of 1 by 1. The RULA activation layer is used to non-linearly change the feature map with the dimensions of 1 by 1. The size of the output data is limited to a 0 and 1. And finally, the propagation map is learned. Finally, we estimate the transmission map by minimizing the loss of a function between a reconstruction transmission, that is T of x, and the corresponding ground truth map is capital T of x, where m is the number of images in the training set. So for a further presentation, I request Ranveer to please present the further presentation. Thank you.
I'm Ranveer Patel and I will be explaining the hardware used in this course. Here we have used a Raspberry Pi 3 model, that is a third generation model which maintains the same popular board format as the Raspberry Pi 2 and Raspberry Pi D+, but boasts a faster 1.2 GHz 64-bit SoC and onboard Wi-Fi inbuilt. It is recommended to use a 2.5 ampere power supply with the Raspberry Pi 3. Specification: here we have used a Broadcom BCM2837 chipset, a 1.2 GHz quad-core ARM Cortex-A53 which is 64-bit, and 802.11b wireless LAN and Bluetooth 4.1. The GPU used is dual-core Quidco coprocessor, which provides an OpenGL ES 2.0 hardware-accelerated OpenGL and 1080p 3 megapixel of camera. Here, over 1 gigabyte of LPDDR2 memory is used, and the operating system boosts from microSD card, running a version of Linux operating system or Windows 10 IoT. The dimensions are 85 into 56 into 17 mm. Here, a micro USB socket which has 5 volt 2.5 ampere power. Here we use a VGA, that is videographic array camera, which has a resolution of 800 into 600 pixel and 24-bit camera. Here are various software used, which are Anaconda, OpenCV, Python, and Spider. In this process, we have used the Spider software. Spider is an open source cross-platform integrated development environment for scientific programming in Python language. Spider integrates with a number of prominent packages in the scientific Python stack, including NumPy, SciPy, MATLAB, and etc. Initially created and developed by Pierre Rabot in 2009, since 2012, Spider has maintained the continuously improved by a team of scientific Python developers and the community. Spider is extensible with first-party and third-party products, includes support for interactive tools for data inspection, and embeds Python-specific qualities, assurance, and introspection issues. It is available cross-platform through Anaconda on Windows, Mac, and Linux. Spider uses Qt for a GUI and is designed to use either of PyQt or PySar in Python build. Its features are it supports multiple IPython consoles, the ability to explore and edit variables from GUI, uh, a debugger link to IPHD, or step-by-step execution. It also helps in runtime profile to benchmark code, and it has a built-in file explorer for interacting with the file system and managing projects. Here are the results. In this, the aim of quantitative analysis is to complete detailed description. No attempt is made to assign frequencies to the linguistic features which are identified in the data, and rare phenomena research. The same amount of attention as more frequent phenomena. The qualitative analysis allows for fine distinction to be drawn because it is not necessary to show the data into a finite number of classifications. Ambiguities which are inherent in human language can be recognized in this analysis. Quantitative analysis. In quantitative research, the approach is to classify features, count them, and even construct more complex statistical models in an attempt to explain what is observed. Finding can be generalized to a larger population, and direct comparison can be made between two cortex. So, as long as valid sampling and significance techniques have been used, the quantitative analysis allows us to discover which phenomena are likely to be genuine reflection of the behavior of a language or variety, which are merely chance occurrences. The more basic task or a task of just looking at a single language variety allows one to get a precise picture of the frequency and rarity of particular phenomenon, and thus the relative normality or abnormality. It has various advantages like it is highly accurate, it is very generalized, and it has improved visibility for underwater analysis. These applications are used very widely, such as in National Geographic Channel, underwater surveys, marine archaeology, and marine geology. Here is the conclusion. The system is first evaluated on a single image and performs the qualitative and quantitative analysis. The system uses a deep learning algorithm to generate the model feature. The trained model is portable model which can be used for testing the unknown underwater or foggy image on video. The results will be a clear haze image. The system can be implemented on the Raspberry Pi hardware platform. The quantitative analysis of a focus system shows the input underwater image is enhanced at expected level. The quantitative analysis of the focus system shows the transmission as well as a residual loss are minimal after 150 image. The future scope in this process is that the SCP algorithm can be implemented in real-time image processing. The SCP algorithm can be implemented in video processing followed by implementation in real-time video processing. And we can also try to implement the algorithm in Jetson KT1 and Jetson Mango GPUs. Here are some of the references you can go through.